Okay, guys. Once again, I'll welcome you all to my today's session, webinar on SSC CGL. And we are going to discuss chemistry questions from previous year's papers of 2023 and 2024. Right? Fine. Here is your first question. Identify the structural formula for magnesium hydroxide. To answer such type of questions, you need to be aware of valencies of magnesium, means metals and then non-metals, right? I'll change the color of my pen. Here magnesium valency is Mg+2 and then hydroxide is OH minus. Using crisscross method, we need to write the formula, right? So we'll write the symbol of cation first, followed by the symbol of the anion. Then downside, we'll write their valencies. If there is any scope for cancellation, then we'll do that. Else, we'll just cross their valencies and then we'll write it. So we'll get it as magnesium hydroxide. Right? So this would be the correct answer. Right. Okay. We need to rub this off. Second question says that dry ice, ammonium chloride, naphthalene balls, and camphor, all these compounds are an example of. If you see here, dry ice is in the solid state. It's in the solid state. And it directly undergoes gaseous state. Right? Without passing through liquid state. What I mean is ammonium chloride, again from solid to gas directly. Naphthalene from solid to gas. Camphor also same from solid to gas. And the phenomenon in which solid substance directly gets converted to gas without passing through liquid medium is said to be sublimation, and all such substances are known as sublimable substances. So option 3 would be your answer, right? And which of the following is not a physical change? How do we identify whether a change is physical change or chemical change? Suppose if in a change, there is no formation of a new substance. Okay. Then we consider that change as a physical change, right? So change in state, change in color, change in size. And if those changes are accompanied by reversibility, then all those come under the category of physical change, right? But we are supposed to answer taking into consideration not a physical change. Then heating of iron rod to red hot. There is no change in composition. So this is a physical change. And then sublimation of ammonium chloride. When it undergoes, it gets converted from solid to gas again. So it's also physical change. Evaporation of diesel, again from liquid state to gaseous state. Change in state is not considered a chemical change. So this is also a physical change, right? So curdling of milk. Here we cannot get back milk again, right? And because of the change in the pH, milk is going to curdle over there. So this is a chemical change. This is a chemical change. So as we are trying to identify not a physical change, this should be the correct answer, right? Fine. Moving ahead. Why does the milkman add a very small amount of baking soda to fresh milk? I guess every one of you might be knowing the answer for this. Very simple question. Fresh milk will have a pH of around 6. Okay. Decrease in the pH value around 4.5 to 4.8 to 4.5. causes casein in the milk to get separated out. Milk is actually a colloidal solution, right? So if we want the milk to stay in its colloidal state, we need to have either pH of 6 or greater than that, right? Because as time passes, bacteria converts that lactic acid in the milk to means lactose, which is there present in the milk, gets converted to lactic acid, right? So to make it slightly alkaline, this milkman will add anything which adds alkalinity to the milk. Generally, they'll add either urea or sodium bicarbonate. So to reduce the pH of the milk from no, it cannot be the case because from 6 to slightly alkaline. To reduce the pH of the fresh milk from 6 to slightly more acidic, no. To maintain the pH of the fresh milk at 6 for a longer period of time, to increase the pH of the fresh milk from 6 to slightly alkaline. We are trying to increase the pH above 6, right? So this should be the correct answer. This is given as reduce, so this cannot be the option. This is also, we cannot make it to stand on the same pH value for a longer time, right? So 4 will be the correct answer, right? Moving ahead. Okay, this is a question related to balancing of chemical equation. How many carbon dioxide and water molecules will be there in the product side if the following equation is balanced? Okay. Suppose if such questions are given to us, we need not waste in time balancing the equation. We can just look at this. It is given as C2H5OH, right? Plus O2. However many carbon atoms are there on the reactant side, same number of carbon atoms will be there on the product side, right? As we have only carbon seen in only this compound, this should obviously be 2. So there is only one option with 2 over here. So even you, without completely balancing also, you can find this option to be the correct one, right? But still, if you balance this, you will get it as here 5 hydrogens are 5 and plus 1, 6 hydrogens are there. Here 2, so we need to put in 3. So automatically oxygens would have been balanced. You can check it back. We have 2 plus 1, 3 oxygen here. Here 4, 4 plus 3, right? 7. So we need to put it here 7 by 2, or we can take 2 over here and then do it. But we are asked to answer only about CO2 and H2O, right? So 2 and 3 respectively. This will be the correct answer. Yeah. This is a balanced chemical equation. If you want, you can take the screenshot. Okay. Next question is, which of the following chemical reactions takes place when quicklime reacts with water? Formula of quicklime is calcium oxide. Okay. And this is a basic oxide. Metal oxides, whenever they react with water, irrespective of what metal it is, metal oxides on reacting with water always forms bases. And acidic oxides like SO2, CO2, NO2, non-metal oxides are acidic oxides. When they dissolve in water, they form their corresponding acids. So you need not check in with all the equations. Whichever equation on the product side is showing the base, that will be the answer. Here we are not having this. In this option 2, you can see calcium hydroxide, right? So calcium oxide, when reacts with water, forms a base calcium hydroxide. If you take sodium oxide, sodium hydroxide, lithium oxide, lithium hydroxide, right? So this will be the correct answer. Next time you might be asked with acidic oxides. There is a possibility, right? Any acidic oxide when reacts with water forms an acid. Non-metal oxides are known as acidic oxides, right? Next question. Identify a monoatomic molecule. Okay. Molecule which is made up of only one atom is said to be monoatomic in nature, right? So here, if you take helium, you write this as He. If you take chlorine, you write it as Cl2. Sorry. Oxygen O2. Carbon monoxide CO. molecule of chlorine is made up of 2 atoms. This talks about atomicity, right? So atomicity is 2, meaning each molecule is made up of 2 atoms. Like that for helium, it is made up of 1 atom. Now this is a compound made up of 2 different kind of atoms, right? But here atomicity, we talk about only for a elemental molecule generally. So helium will be the correct answer. Any inert gas will always be monatomic in nature. Even metals, if you take, you will write aluminium Al, right? Sodium, you will write it as Na. Iron, you will write it as Fe. You don't write it as Fe2, Fe3 like that, right? So all are monatomic in nature, right? Guys, any doubts, you can put it in the chat. I'll definitely answer your questions. Okay. Here, Ernest Rutherford used about dashed gold foil for alpha scattering experiments. Okay. Reference book says that Ernest Rutherford for his alpha ray scattering experiment used 100 nanometers thickness gold foil. If we want to convert it in terms of atoms, we should know what is the size of each atom, right? So one atom size is about 1 angstroms, which will be equal to 10 to the power of minus 8 of a centimeter, or will be equal to 10 to the power of minus 10 of a meter, right? And you know that nanometer is equal to, if I want to express it in meters, I'll write it as 10 to the power of minus 9 of a meter, right? Yes. So here, if I want to write in terms of 10 to the power of minus 10, I'll put one more 0 over here. And then I'll write it as 10 to the power of minus 10 of a meter, right? So if 10 to the power of minus 10 of 1 meter I have, it will be equal to 1 atom. Then 1000 into 10 to the power of 10 meters equal to how many atoms? Simple answer, right? 1000 atoms. So they can ask you either in terms of nanometers or they can ask you in terms of atoms. So this would be the correct answer, right? So option 3 will be the correct answer. Moving ahead. This is for you to take the screenshot, those whoever want to take it. Next question. In the context of periodicity, a unit called picometer is used to measure the. Here in the unit itself, you can see it as meter, right? Something which is talking about length. Atomic radius talks about length. Spin quantum number, it's just the, means like how is electron spinning, positive spin or negative spin. Molar mass, grams per mole, units of which is grams per mole, right? And yeah, atomic density, gram per centimeter cube or gram per meter cube, we write it as. So atomic radius should be the correct option, right? Spin quantum number doesn't have any units. Next question. This is for you. Next question reads, when electricity is passed through water, what kind of chemical reaction occurs? Very simple question. Water is only, means suppose if I write the formula H2O, right? And we are passing electricity through it. One reactant, whenever we supply energy, getting split into more than one substance like this, H2 plus O2. And because this is a reversible reaction, I'll write it this way. One reactant, products more than one. Okay, products more than one. Any such type of chemical reaction in which reactant is one and product is more than one, it is considered to be a decomposition reaction. Suppose if reactants are more than one, product is only one, then it will be a combination reaction, right? Displacement means one element which is active going to displace another one from its salt solution, right? We can see some more examples in other questions too. Next question. This is for you to take the screenshot. Okay. From which Latin word is the S block element calcium derived? Calcium, actually, the symbol of calcium is not derived from the Latin word, but calcium, we get it from a mineral known as calcite. Okay, we get it from a mineral known as calcite, formula of which is CaCO3, calcium carbonate. So major component of calcite will be marble, whose formula is calcium carbonate. And because we are getting this from this, and we can also get it calcium oxide from this one, because these are the sources of calcium. And in Latin, we name these substances as calx. That's why this element, calcium, has been derived from the word CaLX, right? Otherwise, its symbol hasn't been derived from the Latin. This difference you need to notice. Okay. And these has nothing to do with the Latin origin, right? And you let us see this one. This is something which is related to football in Italian word. It's in Italia. Means like in Italian, we consider this word as a football. What I mean is, and this one refers to a genus of flowering plants. And this doesn't have anything to do with the Latin word. And this is what is the correct answer, right? Meaning of which is line in the Latin. Next question. AU is the symbol for which of the following elements? There are about 8 to 10 elements whose symbols has been derived from either Latin word or from a Greek word or from a German word. Greek and German only we have 2 such elements, but remaining all other are from the Latin origin. So even AU is also one such symbol which is derived from the Latin word aurum, and it is for the gold, right? And it is a symbol of the gold. Gold AU, aluminium will write it as AL, silver we write it as AG. This is also taken from the Latin origin name, that is argentum, and argon is ER. So let us see few of the other elements that has been, whose symbols has been taken from their Latin words. Yeah, your antimony. Frequently you can see antimony being asked number of times. Antimony, right? And then copper is derived, means taken from its Latin name cuprum. Gold aurum, this is what is aurum. AURUM, aurum. And silver is, iron is ferrum, lead plumbum, potassium kalium, this is also very important. Asked number of times in the examinations. And silver argentum, sodium natrium, tin stannum. These are the 2 which hasn't been taken from the Latin word, but they have their origin. Tungsten taken from wolfram, which has its origin from German, and then mercury hydrargyrum, which is from Greek, right? This is what it does, but you need to by heart this, otherwise you cannot attempt. Next question. What is the percentage composition of the element of H2SO4? Okay. How to do this? You need not calculate everything, means like for you to get the answer. Simple trick over here is, what's the meaning of percentage composition? What is the amount of the substance by percent present in that particular compound? Meaning of that, right? So I need to know the weight of the substance in that particular compound, weight of that element in that particular compound, divided by the total weight of the compound, into 100. This will be the formula. Suppose if I want to find out for hydrogen, there are 2 atoms of hydrogen, so 2 into atomic mass of hydrogen is 1. Divided by total mass of sulfuric acid, I'll get it as 98 if you try to find it out, into 100. Yeah. So I'll get some percentage, right? If you see this H2SO4, it's very clear that we have 2 hydrogen atoms. Mass of atomic mass of each hydrogen is 1. Sulfur is only 1 atom is there and atomic mass is 32. And oxygen, we have 4 atoms. And then atomic mass of this is 60. Which one is in more number? Obviously this, right? This is 64 grams. This is about, means like in 1 mole I'm talking about. This is 32 grams in 1 mole. This is about 2 grams in 1 mole. So if that is the scenario, obviously this should be in the highest percentage. This should be in the least percentage, right? So hydrogen should be in the least percentage. Next should be sulfur. Next should be oxygen. So whichever is matching that, that will be the correct answer, right? So I guess here 2.5, 5 point, yeah. This one is the correct answer. You can find out, you can calculate and then check it back. Formula is this. Weight of that particular element in the compound divided by the total mass of the compound into 100. You can see in the next slide, I have shown you the calculation part. This is what is the calculation part of this. Okay. Generally, they'll ask you in such a way that you can eliminate other options very easily. Next question. Which of the following statements is incorrect? Okay. Fats and oils are oxidized. They become rancid. What's the meaning of rancid? Rancid is something which talks about spoilage of food matter due to the oxidation of fats and oils present in it. Okay. The phenomenon is known as rancidity. Rancidity. Rancidity is something which is associated with oxidation, but not reduction. Whenever fats and oils present in the food react with oxygen, okay, then they we can see foul smell in it, okay, and this process is known as rancidity. Someone wants to speak up? Any doubt in this? Yep. Question, please. Okay. Rancidity here. So rancidity, no doubt, is associated with foul smell, bad smell. Okay. Odor will be changed, taste will be changed. But it is associated with oxidation. So not reduction. Fats and oils are oxidized, they become rancid. Fats and oils gets reduced over time, and we are trying to identify incorrect statement, please. So this is a correct statement. Fats and oils gets reduced, no, they get oxidized, so incorrect statement. Antioxidants are added to foods containing fats and oil, yes. Antioxidants like butylated hydroxyanisole, butylated hydroxy related compounds or toluene can also be added in order to stop this free radical mechanism which goes on during this rancidity, right? So this is also a correct option, means like correct statement. Chips manufacturers usually flush bags of chips with the, yes, this is also the correct statement, right? So we are trying to identify the incorrect statement. So option 2 will be the correct answer. Option 2 is the answer. Next question. Which number is called Avogadro's constant, named after the 19th century scientist Amedeo Avogadro? This is we need to by heart, right? So Avogadro number is something which talks about how many number of ions or species or atoms will be there or molecules will be there, whatever, means like you will take it as in 1 mole. If I take 1 mole of any substance, then what will be the number of entities present in it is measured by this number, which is nothing but 6.023 into 10 to the power of 23. This is not, means like this is a, means like a recurring number, right? Where do students get confused is, they'll try to write this as 6.022 into 10 to the power of 34. I don't know why. most of the students go wrong in writing this value, but it is actually 23, right? And sometimes they'll write even 27. Maybe they get confused with Planck's constant number and all. They might, or 19 also, usually. But the correct option is 23, right? 6.023 into 10 to the power of 23. Next question. When did Carl Pauling received the Nobel Prize in Chemistry for his research into nature of the chemical bond and its applications to the elucidation of the structure of complex substances? Linus Carl Pauling received Nobel Prize twice actually. In 1954, he received for his contribution towards chemical bonding. Okay. And again in 1962, he received Nobel Prize for Peace, Nobel Peace Prize in this year, 1962, for his advocacy in the nuclear disarmament, right? So he said that nuclear tests should be banned and all. For that, he received the Nobel Prize. So he is the scientist. He is the only one scientist, I think, who has received Nobel Prize twice unshared, what I say. I'm not saying, means like he's the only one to receive Nobel Prize twice, but unshared Nobel Prize, right? You can see the description of it. Here I have written. If you want, you can take the screenshot. Next question. The type of reaction that is typically found when a material that is required for the reaction to proceed, such as a surface or a catalyst, is saturated by the reactants is called a dash order reaction. Generally in SSC, in any SSC examinations or competitive examinations, when they are asking about order of the reaction, either they'll ask you about zero order reaction or first order reaction. Okay, they don't go beyond that because they need to give the reaction. Otherwise, they need to talk about the conditions so that you'll get an idea. So if you don't know any answer will be either from zero or from the first order reaction, right? So we can eliminate this second order as well as this third order. And whenever you see surface or a catalyst reactions, then generally when the surface of the catalyst gets saturated, concentration of the reactant will never come into the picture, okay, to count into the order of the reaction. So it will always be a zero order reaction. Whenever you see a metal and then a catalyst, and you asked about the order of the reaction, simply choose zero order, right? It will always be zero order because it doesn't depend on, means like order of the reaction will be independent of the concentration of the reactant over there. Moving on to the next question. Yeah, here is the description part if you want. Similar type of question means what I did is similar type of questions that have been asked in 2023 and 2024 related to the same concept. I placed it at one place. Right? So the decomposition of gaseous ammonia on the hot platinum surface is a dash order reaction at high pressure. Again of the similar type. You are able to see a gas. This is a gas phase reaction. And then hot platinum surface. Here platinum acts as a catalyst. And again it is a metal surface. So it should be zero order. It should be zero order. This is what is the explanation. You can take screenshot. A chemical reaction. Next question. A chemical reaction in which the rate of reaction is directly proportional to the first power of the concentration of the reacting substance is called. They have clearly given that first power of the concentration, right? First power of the concentration means it should be first order. Second power of the concentration means it will be second order, right? So rate of the reaction will be directly proportional to rate of the reaction will be directly proportional to the concentration of the reactants raised to the power. If this is 1, then it will be first order reaction. If this is equal to 2, that will be second order reaction. Because they have given first power of the concentration, first order reaction. Hope it's clear. Next question. For a chemical reaction with rise in temperature by 10 degrees centigrade, that is actually 10 degrees centigrade, the rate of constant becomes, okay, they're talking about rate of constant. This is given by Arrhenius expression, and generally, whenever temperature increases by 10 degrees, rate of the reaction doubles, simply doubles, because molecular collisions increases to that rate. Okay, and also, even if you calculate also, if you are given the numericals, if the temperature is 10 degrees, exactly the rate constant would have been doubled, right? So the answer is double over here. I don't want to go in too much of the explanation of this. If you want, you can take the screenshot of this. This is Arrhenius equation, which is given by this expression. I have seen even this expression being asked in the previous year examinations. A is equal to A into e to the power of minus EA by RT, where EA is the activation energy, right? So approximately it doubles. Next question. What is the product formed? Is this the next question? Yeah. What is the product formed when zinc and sulfuric acid reacts? Again, to answer such type of questions, you need to be aware of metal activity series. Okay. Any metal which is active, I can say active metal, when it is added with dilute mineral acid, dilute HCl or dilute H2SO4, then it results into the formation of a displacement reaction takes place. Active metal displaces hydrogen from this mineral acid and then forms its metal salts, corresponding metal salt plus hydrogen. This is what is the general reaction of this. Now they have given zinc here. So zinc is an active metal because it is above hydrogen in the metal activity series. I'll show you now. Plus sulfuric acid, H2SO4, whether it is concentrated sulfuric acid or whether it is dilute sulfuric acid. Irrespective of that, you will get zinc sulfate. If it is dilute, then you'll get hydrogen as a gas. If it is concentrated, then you'll get sulfur dioxide as a gaseous product, right? But because they have given the salt here, so zinc sulfate would have been the correct answer, right? Now I'll show you the explanation part of this. Yeah, here. This is what is metal activity series. How do we know which metal is active? Here, any element which is above hydrogen in this series, only those elements which are of important and is frequently asked, I have put it in the list over here, right? All type of the coinage metals will generally be more reactive than hydrogen. So you can see this is taken as a standard. This is taken as a standard. Elements which are below this will be less active. Metals which are there above this will be more active. Any of these metals, when they react with dilute mineral acids, except HNO3, I'm not talking about HNO3, HCl and H2SO4, then they give, means because they displace hydrogen from the acids, we get hydrogen as one of the products, right? You can see 4 such kind of questions as I move ahead, right? And if these metals react with these dilute acids, you don't see any reaction, right? Active metal, this is what is the reaction. If it is concentrated given, you need to be, like you need to read the question, understand the question what is given, whether it is dilute or concentrated being given in the question. If it is concentrated, you will get sulfur dioxide because this is a strong oxidizing agent. Now, moving ahead. I clear my drawings. Similar type of question over here. Which of the hope you guys can answer this question? Which of the following gases get released when dilute sulfuric acid reacts with magnesium? Again, magnesium is above hydrogen in the metal activity series. So it's an active metal. Wherever there is active metal, hydrogen gets displayed. So hydrogen will be the correct answer. Right? Because you can see magnesium over here. Here we have hydrogen. Here we have magnesium. Above hydrogen. So H2 will be the correct answer. Suppose instead of dilute sulfuric acid, here you see concentrated sulfuric acid. Then what? Sulfur dioxide would have been the correct answer. Right? Next option. Sorry, next question, sorry. What is the gas evolved when zinc reacts with sulfuric acid again? What is the answer? Exactly. Hydrogen is the correct answer. Now, every time we don't get the same type of question, right? We also need to understand under what scenarios these options would be getting correct. When can I get carbon dioxide as correct? When sulfuric acid is reacting with dilute sulfuric acid, I'm talking about. When dilute sulfuric acid is reacting with any carbonate salt, meaning metal carbonate, then we always get carbon dioxide as the gaseous product. And metal salt, obviously, right? I'm talking about gaseous products over here because that will be frequently asked in the examination. Suppose, let us say I have metal sulfides, metal sulfide plus dilute sulfuric acid. Then we'll get H2S, hydrogen sulfide as the gas. So this option will be correct if instead of zinc, you are given with metal sulfide. For example, iron sulfide, zinc sulfide, okay, lead sulfide, we'll get hydrogen sulfide. If they give you metal carbonates like CaCO3 or sodium bicarbonate, sodium carbonate, whatever it is, any metal carbonate gives carbon dioxide. Now, hydrogen we have already talked about. In this case, we'll get hydrogen here. Now, oxygen. Suppose, let us say peroxides are reacting, peroxide plus dilute sulfuric acid. Then we generally get oxygen. Right? So oxygen would be the answer here if I have peroxide. Carbon dioxide will be the answer here if I have metal carbonate. Hydrogen sulfide will be the answer when I have metal sulfide. We need to make it a practice that always under what scenarios which option will be correct, right? Every time we can't get questions of this same style, right? Any doubts related to this, please put it in the chat. This is for you to take the screenshot. Next question. Which polyatomic ionic compound is a white crystalline powder used in fire extinguishers and to neutralize acids and bases? Wherever you see fire extinguishers, generally, fire extinguishers extinguish fire using carbon dioxide, isn't it? Carbon dioxide being heavier than oxygen, carbon dioxide displaces oxygen from the air and acts as a barrier between the fuel and the oxygen, thereby extinguishing fire. So fire extinguishers uses those substances in the fire extinguishing chamber, okay, which can give carbon dioxide, right? Any metal carbonates, just now I told you, any metal carbonates, when they react with acids, we get carbon dioxide as one of the products. So let us search in the options. Where is the carbonate salt? We are able to see bicarbonate here. Whether it is sodium carbonate, sodium bicarbonate, any type of metal carbonate, when it reacts with acid, gives carbon dioxide. So typical fire extinguishers which we are going to use will be acid fire extinguishers to get carbon dioxide, right? If we are trying to extinguish fire using carbon dioxide. So this will be the correct answer. So wherever you see fire extinguishers, try to search for carbonate salts. That's it. Next question. And reaction is also given here. You can check it. We are getting carbon dioxide. Next question. Which gas is evolved when iron and water react? Similar type of question again. Active metals whether they are reacting with dilute acids or they are reacting with water. They can displace hydrogen. Whenever hydrogen gets displaced, it comes out in the form of hydrogen gas. Okay, it comes out in the form of hydrogen gas. So answer will be hydrogen only. All these are examples for single displacement reactions. Next question. This is the reaction for this. Yeah, even this one also you need to remember. You can be asked that, and here iron cannot react with water directly. Water should be meaning like superheated, or it should be in the form of steam. And even iron should also be red hot. Right? And what is the product form? This is asked number of times. Ferrous-ferric oxide, or we can also call it as mixed oxide. This is known as ferrous-ferric oxide or mixed oxide. When red hot iron reacts with steam, we get ferrous-ferric oxide. Right? Next question. Which acid is used as a souring agent added to vinegar, pickled vegetables and sauces, and as a raw material for seasoning? Okay. We don't add it to vinegar. Actually, vinegar itself is 5% acetic acid. 5% acetic acid is known as vinegar. Acetic acid is one of the components of vinegar. We don't add it to vinegar, right? Okay. Pickled vegetable sauces. Yeah, answer itself is acetic acid. We don't add citric acid, formic acid or tartaric acid, but we add citric acid. Sometimes I have seen sources being asked, sources of citric acid. Any citrus fruits can be the sources of citric acid. Formic acid, ants are the sources of formic acid. Tartaric acid, grapes. Okay, we can see tamarind, we can see tartaric acid. So they can ask you from which source is this particular acid. We can get this particular acid. Such type of questions are also asked. Next question. When you take lead nitrate powder in a boiling tube and heat it, you will observe the emission of brown fumes that are of dash. Any metal nitrate, it's not only lead nitrate, zinc nitrate, silver nitrate, okay? Any metal nitrate, they can change the metals, but the compound is something which is related to metal nitrates, right? Nitrates upon heating, they undergo decomposition to form metal oxides plus nitrogen dioxide plus oxygen. This is the general equation. If in the option you can see oxygen, then also it will be correct. But because in the question they have given brown fumes, suppose let us say one of the options here is oxygen, then also it will not be correct. Though in the reaction we are getting oxygen, this oxygen is colorless in nature. Red nitrogen dioxide is the one which is having reddish brown color. Reddish brown color. Because they have given brown fumes, nitrogen dioxide will be the correct option, right? And there is an exception. Generally, exceptions are more important. All alkali metals, first group element, they don't, means like on decomposition, they don't give oxides, but instead they give nitrites. For example, if I take sodium nitrate, this is alkali metal. Upon heating, it gives sodium nitrite plus oxygen. We'll get only oxygen, but we don't get nitrogen dioxide. This is very important. Okay, these are exceptions. All first group elements, alkali metals, upon heating, they don't give you reddish brown fumes, but instead you can see oxygen gas, colorless oxygen gas. Whereas all other metal nitrates, they give both the types of the gases, but if it is reddish brown, it is nitrogen dioxide. Moving ahead, very important, guys. This is asked number of times in the competitive examinations. This is what is for you. You can take the screenshot if you want. Next question. What was Antony Laurent Lavoisier's most important contribution to chemistry in the year 1789. Okay. Irrespective of the year, wherever you see Lavoisier, he is associated with law of conservation of mass. And what all other things you can see the questions related to Anthony Lavoisier. In the same year, 1989, he has also grouped the then known elements. Okay, tried to classify the elements then. So he tried to group the elements into 4 different categories. Okay, later on it was not accepted. That's a different story. But he was the first scientist to group the elements into 4 categories. Right. And he is the scientist who is associated with disapproving of phlogiston theory. I'll show you here. Phlogiston theory, very important. This is also asked number of times. And also he is known as father of modern chemistry. These are the 4 categories into which he divided the elements: gases, metals, non-metals, and then earths. Right? And he is the scientist who is associated with disapproving of phlogiston theory. What is phlogiston theory and all about? I'll talk about in the next coming questions. Right? And he is the one who formulated the law of conservation of mass. These are the 5 things which are associated with Anthony Lavoisier. And these are which are frequently asked. Right? Take the screenshot if you want. Next question. Which German chemist and physicist proposed that an aromatic compound must have an odd number of pair of electrons, which can mathematically be written as 4n plus 2, okay, pi electrons in 1931. Now, to answer such type of questions, this is not of class 10. This is definitely of intermediate, right? Plus means like 11 and 12th class. So non-science students will face difficulty to answer such type of questions. We can use elimination method here. Anthony Lavoisier is nowhere associated with this. We can eliminate this option. And Rosalind Franklin, you would have learned in your, during your, means like 8th, 9th or 10th in biology, that he's the scientist who is associated with DNA structure. Okay. He used X-ray diffraction method in order to elucidate this DNA structure. So we can even remove this option. There are 2 more options. Frederick Kekule is the one who talked about benzene structure as cyclic, okay, hexagonal with alternate single and double bonds. He is the one who talked about the structure of benzene. So he is also not associated with aromaticity. Aromatic compounds are those which are planar in nature and which are having 4n plus 2 pi electrons. 4n plus 2 pi electrons. So this is known as Huckel's rule. So Eric Huckel is the scientist who is associated with this Huckel rule. So this is the correct option, right? For the explanation part, you can see this. You can take the screenshot if you want. Next question. Trichloromethane is better known as. Formula of methane. Very simple, right? Formula of methane is. This is, you have learned it in your school level. This is what is methane. Each carbon bonded with 4 other hydrogens. Suppose if these 3 hydrogens are replaced with chlorine. Cl, 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 and then H over here. Only 3 hydrogens got replaced with chlorine. This is known as trichloromethane. Okay, trichloromethane. But in the early IUPAC naming, CH group is said to be formyl group. Formyl group. Okay. Formyl group is substituted with 3 chlorines. Trichlorinated formyl. Trichlorinated formyl. So from trichlorinated formyl, this chloroform has been derived. Chloroform. This is also asked in your competitive exams, right? So chloroform, we got this name from trichlorinated formyl. So chloroform is the correct answer. So this is what is the explanation part of that. Butanes are alkanes. LPG gas are hydrocarbons. Hydrocarbons, they contain only carbon and hydrogen. Laughing gas is N2O. So these cannot be the options. Next, moving ahead. Which of the following is used to chemically test starch? Wherever you find starch, iodine will be the option. Testing part, what I say is, if we are trying to test starch, we use iodine solution. If we are trying to test iodine, then we use starch solution, right? Starch, whenever it is added with the solution of elemental iodine dissolved in potassium iodide or sodium iodide, then you can see starch triiodide complex formed. Starch complex. I'll just write this. I'll write like this. Color of this complex is dark blue, you can say, or blue-black, right? So iodine solution is the one which is used to test the starch. Even in very minute quantities, if starch is present, we'll get the positive test for that, right? So iodine solution will be the correct answer. Suppose if in the question they'll give you testing for iodine, downside if starch solution is given, that will also be correct, right? And this is a reversible reaction. On heating, we'll get back the starch and iodine solution back. You can take this screenshot. Next question. To which group do the alkaline earth metals such as radium, barium, strontium belong? They all belong to group A. Now I'll show you the periodic table and what will be the related questions that can be asked on that. This is what is the periodic table. We have in the this is modern periodic table. Modern periodic table elements have been, meaning like they are placed in rows and columns. We have 18 such columns and then 7 such type of rows, right? Rows are known as periods and these columns we are calling it as groups. So 18 groups we have. We have 18 groups and then 7 periods. 7 periods. First group elements are known as alkali metals. This also I have the picture. I'm showing. Yeah, can you see this? First group elements are known as alkali metals. Second group elements are named as alkaline earth metals. And here in alkali metals, hydrogen is excluded, please. This is very important. The element that belongs to group 1, but that does not belong to alkali metals is hydrogen. That is also asked in the previous year's papers. Okay, group 2, alkaline earth metals. And then from group 3 to group 12, transition metals. And then we don't have any specific names for 13th group and then 14th group. 15th group are known as pnictogens. P is silent here. Pnictogens. 16th group, chalcogens. This is also asked. You can see that question as I move ahead. 17th group elements, halogens. This is asked number of times. Okay. And then 18th group elements, noble gases or inert gases. Right? Noble gases or inert gases. So you can see this radium, barium, strontium. Here, this is means like complete periodic table is not given. Strontium, calcium, magnesium, you are able to see. But barium, as you move downside, all these elements are belonging to group A. These are alkaline earth metals, right? And this entire periodic table is also meaning like we consider these first group, 2 group elements, we name it as S block elements. Because here the incoming electron is entering into the S shell, right? Similarly, P block element. All these group numbers from, I write it. From 13 to 18. From 13 to 18, these are P block. These are P block. These 2 are S block. And these all put together are known as D block. Here you are not able to see F block elements. Here I have shown you transuranic elements, rare earths, which we call it as lanthanides and actinides. They are placed downside of the table and they are known as inner transition elements or F block elements. Right? Fine. We can see questions on this. Here my drawings. Transition elements are the elements that are found in group 3 to 12 of the modern periodic table that constitute dash. Now you might be knowing the answer for this. Yes, good. D block. Right? D block is the correct answer. Going ahead. Which of the following group elements are called chalcogens? Just now we have seen, right? Group 16th elements are known as chalcogens. Group 17 are known as halogens. You need to practice this. Write at least 5 to 10 times so that it gets into your long-term memory. Group 2 elements are known as alkaline earth metals. Alkaline earth metals. And group 18 elements are known as inert gases or inert elements. Right? Or zero group. 18th group is also known as zero group. Yes. Yeah. What will be the atomic number of an element? 1 second. I'm able to see questions in the chat. What will be the atomic number of an element X, which is placed in period 2 and group 17? To answer all such type of questions, whenever period number and group number is given to you, it will give you the clear indication, meaning like by knowing this, we can find atomic number, what I say is. So in the period talks about how many shells we have, number of shells. Group number tells us number of valence electrons. Number of valence electrons, right? They have given period 2, meaning we are having K and L shell. Group 17 means they are supposed to have 7 electrons in their valence shell. If L shell is having 7 electrons, K shell means obviously it possesses 2 electrons. Now the sum total comes out to be 9. This is nothing but the total number of electrons present in the neutral atom. Electronic configuration always gives us the number of electrons, but not number of protons. But we know that in any neutral atom, number of electrons will be equal to number of protons. So if these are number of electrons, then protons are also equal to 9. Protons will also be equal to 9, right? So proton talks about atomic number. This is equal to Z. Element with atomic number, Z is nothing but fluorine. This is what is this element, right? So what will be the atomic number of an element X? Answer is 9. If element is asked, then it is fluorine. Okay. Next question means like how to do this. I have shown you. If you want, you can take the screenshot. Okay. Which of the following are metalloids? Metalloids are those elements in the periodic table which will show the properties of both metals as well as non-metals. Generally, metalloids will be placed on the right-hand side of the periodic table. Okay, you can't see it on the left-hand side. Because from left side, metals will start. As we proceed to the right side, we can see non-metallic character increasing. So metallic character decreasing. Now we'll see metalloids. Then as we again shift it to the right side, we can see non-metals. I'll show you the periodic table first, like this. Okay. So these are all metals. Mostly we have metals in the periodic table. Now as you are moving ahead, you can see these which have been meaning like highlighted are metalloids and the remaining are non-metals, right? So we are actually having 7 means like metalloids. What are those are? You can see boron. Once again. We can see this boron, silicon, germanium, arsenic, antimony, tellurium, and then polonium. Polonium is a radioactive element. You can exclude this. All these are considered to be the metallites, right? Now, if you see here, aluminium is given in the first option, cannot be the answer. So, boron, silicon, antimony, correct choice. So, this cannot be the answer. This cannot be the answer, right? So, boron, silicon, germanium, arsenic, antimony, and then tellurium. All these are metallites. Next question is also about metallites. Which of the following elements is a metallite? Now you can easily answer this, right? Sodium is a metal, oxygen non-metal, iron is a metal. So silicon is the one which is a metallite. Silicon is metal, right? Next. Which element's atomic number in the periodic table is named seaborgium according to the one second, I'm not able to see the question here. Seaborgium according to the notation of IUPAC nomenclature. Seaborgium is the name given to the element annilhexium. Annilhexium. This is actually synthetic element. Okay. So they have synthesized this element and its atomic number is 106. But in 1997, during the systematic naming using the IUPAC nomenclature, this particular element was named after a Nobel Prize winning nuclear chemist, Glenn T. Seaborg. Glenn T. Seaborg, right? And this was done in the year 1997, okay? For his contribution towards transuranic elements. He has done much of his research on transuranic elements. So he is given that credit, right? You can see the explanation part if you want, right? So actually, before seaborgium name was given assigned to this element, it was annilhexium, right? Annilhexium, and atomic number of which is 106. Identify the last element from the fifth period. Any period ends with inert gas. Okay, any period ends with inert gas. I already told that we are having 7 periods, right? So for first period ends with helium. Second period ends with neon. Third period ends with argon. Fourth period ends with helium, neon, argon, krypton, xenon, and then radon. This is a radioactive element. They're asking about fifth period, so it should be xenon. It should be xenon, right? And the rubidium, it belongs to 1A group. And then helium is this first period. Yttrium, no, it has nothing to do with the inert elements, right? Yttrium is actually third group. Next question. Yeah, here you can see helium, neon, argon, krypton, xenon, and radon. Next question. Which of the following gases plays an important role in welding titanium, aluminum, stainless steel, and magnesium? Okay. They have given fluorine, chlorine, neon. Generally, we use for welding purposes inert gases. Okay, inert element should be preferred so that it can protect that metal from undergoing reaction with oxygen and nitrogen or moisture which is present in the atmosphere, right? So because we are talking about welding of the metals, we need to choose an inert element. Now there are 2 inert elements given in the option, argon and neon. But generally argon is preferred because it exhibits high inertness, right? So we use argon as one of the gases for welding purposes. Here is the description part. This is particularly used in case of tungsten inert gas is used for welding of the metals like all these what they have mentioned in the question, right? To protect against reaction of these metals with oxygen, nitrogen, and moisture. Next question. Which of the following gases emits red light when electricity is passed through it? Okay. Whenever electricity is passed through it, what is that? They have given argon, neon, hydrogen, and helium. Okay. We can see a very distinct reddish orange color only with neon. Only with neon, right? We can see a slight tinge red color with other elements, gases also, but reddish orange distinct color is noticed only with neon. And coming to argon, you can see it as a violet color, okay, violet glow. Coming to hydrogen, you can see reddish pink or like purple pink, purple and pink combination. Helium, you can see it as yellowish white in nature. Okay, yellowish white. These can also be asked next time, right? So better to remember and take the screenshot also. This is what is the description part. Argon, pale blue or violet light. It's bluish shade we can see. Neon is the one which shows the reddish orange glow, very distinct color. You can easily notice that. Hydrogen, pinkish red or purple glow, very light, not that dark in nature. And then helium, yellowish white. Which of the all these questions are nothing but they are given under the applications of inert gases. Generally, from the modern periodic table, you can see questions related to either 17th group or 16th group, first group, second group, and the last group. Only these you can generally see the questions, right? And coming to group 18, they can ask you either the name of that particular element or atomic number of that particular inert gas, or they can also ask you about the application. Where do we use that, right? Generally, what I have noticed is in all group 18 elements related questions, they ask the application part of it. Right? Which of the following is used? This is also an application part of that inert gas element. Which of the following is used as a cooling medium for the Large Hadron Collider and the superconducting magnets in MRI scanners and NMR spectrometers? Generally, for cooling, okay, for superconducting, we use element with the, we prefer helium here. We are supposed to use any element with the lowest boiling, lowest boiling point. Meaning it helium is approximately 270, correct value if you want to write 269 point something, right? Degree centigrade. This is what is the boiling point of helium. If you go for neon, this will be around minus 246 degrees centigrade. Very nearer, but this is least one, right? That's why we prefer helium. Coming to argon, it will be around minus 186 or so. Chlorine, we know it is means like it will be very higher value, right? So helium is preferred as a superconducting medium, but nowadays neon and hydrogen is being preferred because in order to avoid, means like helium is costly first of all, and we need to bear its evaporation losses. So in order to overcome all these things nowadays, as a pre-cooling medium, we are using neon and hydrogen, right? Suppose if in the question you can see pre-cooling medium, then you need to choose the option either neon or hydrogen. But if they just ask you cooling medium, because primarily only helium is preferred, right? Helium will be the correct answer, right? Fine. So explanation part of this, if you want, you can check it. This is what it is. Chlorine at any means like we can eliminate it. So there will be confusion between helium and neon. That's it. But primarily because we are going to use helium, that will be the correct option. Next question. Identify an example of plasma as a state of matter. Okay. Plasma state consists of ions. So blood, it's a colloidal solution which is in the liquid state. It is not in the plasma state. Freon, it's in the gaseous state. It occurs in the gaseous state in nature. And then dry ice, solid carbon dioxide, which occurs in the solid state. Neon sign bulbs. Here in the neon sign bulbs, we can see neons existing in the form of the ions because of the excitation of the electrons, right? Because during the de-excitation, they emit the light. So neon sign bulbs will be the correct answer because they contains neon ions. Explanation part of this is here. Next question. Which of the following sedimentary minerals known to everyone as salt usually forms in arid climates where seawater evaporates? Zeolite is something which is known as, this is used in the purification of water, means to remove hardness, right? So it is an hydrated compound. Calcite, we know we have already discussed it as CaCO3. Pyrite, FeS2. So halite is nothing but the major composition of which is sodium chloride, right? This is the one which we can see it obtained in the form of salt when the seawater evaporates. So we get chlorides also obtained from this compounds, right? That's why is the name halide given. So this should be the correct option. Let us see the answer. Yeah. Zeolite is nothing but hydrated aluminosilicate. This is an hydrated salts, we consider it as, which is used in the purification of water to remove water hardness. Which of the following is not a halogen gas? What are halogens? Elements that are belonging to group 17. We are naming those as halogens. And we know that fluorine, chlorine, bromine, and iodine. These are the ones which are belonging to group 17. We can see bromine, fluorine, and then chlorine. So helium will be the correct option because we are trying to identify not a halogen gas, right? Next question. Identify the element that does not belong to period 6 of modern periodic table. Period 6, here from period 6 elements with atomic numbers greater than Z is equal to any value greater than Z is equal to 54, meaning from 55 it starts. Elements from 55 to 86 come under this category. They belong to period 6, okay, 6th period. And platinum Z value is around 78, tungsten is around 74, rhenium is around 75, silicon is what is 14. So this should be the correct answer, right? So this is belonging to 3rd period, whereas all other elements are belonging to 6th period. Next question. Yeah, here you can see I have come up with the periodic table. You can see here platinum. This is 6th period. 1, 2, 3, 4, 5, 6, right? This is tungsten. This is rhenium. Silicon is here. Silicon is, this is belonging to 3rd period. Next question. Lanthanides are often called lanthanides as well as actinides. They are block elements. Okay. Both come under the category of rare earths because they are obtained from very rare minerals. Okay. So correct answer will be rare earth elements. Neither D block, inert gases nor alkali metals. Lanthanides as well as actinides belong to group 3. Group 3. Lanthanides belongs to group 3 and then 6th period. Actinides belongs to group 3 and then 7th period. This is also asked number of times. Yeah, lanthanides. This is also important for you to remember. Lanthanides range from cerium to lutetium. There are 14 elements. There are 14 elements, right? And in this lanthanide will not include in lanthanide. Lanthanum will not include in lanthanides. Lanthanum atomic number is 57, and this is not the part of lanthanides, right? So from 58th element to 71 element, we are naming those as lanthanides. Yeah, F block elements. Question. Which of the following is a correct order of basicity? Actually, they are not supposed to ask about basicity because someone wants to ask question. Soundarya wants to ask a question. Okay. Here the question should be strength of basic character. Okay, not the order of basicity. Generally, strength of basic character we'll find out by taking into consideration how many OH minus ions is one molecule going to furnish in its aqueous solution. Okay, number of OH minus ions we are going to get, and another one is how readily we are going to get these OH minus ions. How readily? Based on this, we answer we talk about the strength of the 1 second. Based on this, we talk about the strength of the basic character. Now, if you observe in the options, you can see the elements that are given are belonging to group 1. They are belonging to group 1. Okay. So, each molecule will contain only one OH minus ion. It can furnish only, meaning upon dissociation. It can furnish upon ionization. Okay. If it is dissolved in water, it gives a cation. Suppose if I take CS, then CS plus and OH minus. I'm getting only one OH minus. If I take KOH, I'm going to get only one OH minus. So in all these given compounds, I'll get only one OH minus. Now, what should I need to take it into consideration to talk about the strength of the base. I need to take into consideration how readily can they give this OH minus ions. Now, to answer this question, we need to look into the size of the cation. Size of the cation, right? Larger is the size of the cation, readily it can give away OH minus ions in its aqueous solution. So if you see in the periodic table, you can see lithium, sodium, potassium, rubidium, and cesium. Francium, anyway, radioactive element, we are not taking into consideration, right? So here cesium is of the larger size. So this should readily give away OH minus ion, meaning its basic character should be means it is supposed to be considered as the good base, right? Strength of the base is high. So wherever in the option we are able to see CSOH as the first one, that should be the correct option. So this is size wise, if I write CS size is greater than that of rubidium, greater than that of potassium, is greater than that of sodium, greater than that of lithium, right? So obviously CSOH will be of the greater basic strength compared to RBOH, will be of the greater strength compared to KOH, will be of greater strength compared to NaOH, and then LiOH. So this will be the order. Make it a correction. This should be strength of base. Strength of basic character, what I mean is not basicity. Moving ahead. Yeah, this is what is in the periodic table, and you can see the elements. Lithium, and this does not belong to alkali metals. Lithium, sodium, rubidium, potassium, rubidium, cesium. Next question. As per Mendeleev's prediction, atomic mass of Eka aluminium was, okay. Mendeleev gave his periodic classification of elements in the year 1869. Year is very important to note down. And during his, meaning like he was trying to give his periodic table, he left some gaps, predicting that in future, and if at all these elements are discovered, okay, these elements will be having the properties similar to the elements which he has mentioned it as Eka aluminium, Eka silicon, Eka boron, okay, and then Eka manganese, like that. Eka aluminium, later on it was discovered as gallium. And atomic mass of that gallium is 68, right? Okay, I'll show you this table. Yeah. Wherever he left the gap, and he predicted that elements he discovered in the future going to show properties similar to these elements. He named it as, he wrote it as Eka and then given the name of that particular element. Right? You can see here, Eka boron. 1 second, I'll change pen color. Eka boron. Eka boron later on was discovered as scandium, meaning scandium was having properties similar to that of boron. That was his idea. So scandium Z value is 21. If they ask you atomic number, it is Z1, 21. Then atomic mass is 44. Gallium Z is equal to 31. 31, yeah. Germanium Z is equal to 32. Mass is 72. And then manganese and then technetium, I need to check back. And atomic mass is 100 here. Right? Atomic mass is 100. So this is what it is. Similar type of question you can see here. According to Mendeleev's periodic table, which elements' properties matched up remarkably well with Eka silicon? Just now we have seen. I'll again take you back. Eka silicon. It is germanium. Right? Germanium. If atomic mass is asked, then it is 72. But they asked you about the element, right? So correct answer will be germanium. Option 4 is the correct answer. Moving ahead. Next question. In which year did John Newlands propound the law of octaves, an innovative concept proposing the periodicity of chemical elements arranged in the order of atomic weight? Newlands gave his periodic classification in the year 1829. 1829 Doberan year. 1829 Doberan year and 1865, sorry. This is in 1829, Doberan gave his classification. 1865, Newland's law of octaves. 1869, Mendeleev's. And then 1913, Moseley's. You need to remember these years. So as we are talking about Newland's law of octaves, this is the year in which he has given his classification. Okay. Now what he did is, when he was trying to arrange the elements in the increasing order of the atomic mass and also trying to group the elements with respect to the similarities in the chemical properties, he noticed that every 8th element was a kind of repetition of the first one in its properties, just like in the musical notes. Okay, so we have 8 musical notes, right? Sa, re, ga, ma, pa, da, ni, sa. And the 8th note will be a kind of the repetition of the first one again. Because they were matching with those musical notes, his classification is also known as, like, he named it as law of octaves. Right? Year is 1865. 3 such type of questions you can see based on this Newland's law of octaves. And this is also asked number of times, like particular element they'll give you and ask you under which musical note did he place that element. Okay? Lithium is placed under Re. Hydrogen is placed under DO, do, right? Like that. And there is a limitation of this periodic classification also. What is that limitation is, he has placed this coinage element copper alongside the soft elements, soft metals, okay? Coinage metals. And also cobalt and nickel alongside non-metals. That's what is the limitation of this. And also Newland's law of octaves holds good only for the elements up to calcium. Okay? For the elements with higher masses, that is greater than 40, there were like some inconsistencies in the properties we have noticed, right? So this was not accepted. Later on, Mendeleev's gives his periodic table. Similar type of question on Newland's law of octaves. Identify the correct statement about Newland's law of octaves. He started with element having the highest atomic mass. No, atomic mass of hydrogen is 1, right? It cannot be the highest atomic mass. So this is not the correct statement. He started with element having the lowest atomic mass. Yes, this part is correct. And ended at aluminium. No, he ended at thorium. Thorium. And atomic number of which is 56. So this is also not the correct statement. He started with the element having the lowest atomic mass. This part is correct. And ended at thorium, which was the 56th element. Correct statement. He started with the element having the lowest atomic mass. Ended with sodium. No, wrong. This part is wrong, right? So correct option is, correct answer is 3. Next question. In which musical note did Newland put the metals cobalt and nickel with halogens? Okay. Just now I have shown you. Yeah, you can see. Nickel and cobalt he has placed alongside these elements, right? Which are non-metals. And he has placed it under the musical note do, DO. So the correct option will be DO. Right? Even this is also asked number of times, RE. Sodium is placed along, in the musical note, under the musical note RE. And lithium element having the properties similar to that of the sodium. Very important with respect to Newland's law of octaves. Let us see next question again related to Newland's, I guess. Yeah. In Newland's octaves, the properties of lithium and dash were found to be the same. Elements which are belonging to the same group will have same properties because he grouped it that way. Now you can see sodium is having the, is arranged alongside lithium, right? So in the options, you can see beryllium, sodium, aluminium, and magnesium. There is only sodium which is there belonging to this group. So the correct answer is sodium. Correct answer is sodium. Next question. This is about, okay, percentage of silica in cement. See, if we talk about Portland cement, major component of Portland cement, no doubt, will be calcium oxide, but which will be approximately around 60% and anywhere greater than that. But coming to silica, it will be around 20 to 25%. Any value matching with this will be the correct option. So 70 to 25 should be the correct answer. Okay. Portland cement contains, composition of Portland cement, if I talk about calcium oxide 60% and above, and then we need to always talk about a range, not the exact value. And then silica, and we can also see aluminum or alumina, which we call it as Al2O3. It will be around 5% in a range, minimum of 5%. And then we can also see iron oxide, Fe2O3, around 1%. And then we can also see sulfur trioxide around 1%. Added gypsum can be seen. Right? If they ask you about the major composition, then calcium oxide will be the correct option. If they ask you about the percent, because they have asked about the silica percentage, we have chosen this, right? You can take the screenshot if you want. I didn't mention the percentages over here, but just now I have talked about, right? Next question. What is the atomicity of chlorine? In my second question or third question, I said that how many atoms of molecule is made up? Based on that, we talk about atomicity, right? Suppose if I take chlorine, I'll write it as Cl2. If I take hydrogen, I'll write it as H2, right? If I take fluorine, I'll write it as F2. And if I take ozone, I'll write it as O3. Sulfur, I'll write it as Si. Phosphorus, P4. This number talks about atomicity, right? So atomicity of chlorine is, it should be 2, meaning diatomic. Diatomic. If I write helium, this is monoatomic. This is triatomic in nature. Any value greater than 2, we consider it as polyatomic. All these come under the category of polyatomic. Tetraatomic, octatomic, right? So for tetraatomic, answer will be P4. For monoatomic, we can take any inert element, any inert gas as well as metals. Polyatomic, any of these can be taken as an examples. Diatomic, any of these can be taken as. There are many, I have mentioned only a few. Atomicity refers to the number of atoms present in a molecule of an element. Right? Which of the following elements has a variable valency? Valency is something which talks about the combining capacity of an element, meaning how many bonds a particular element can form. Or if you want to talk about in terms of losing electrons or gaining electrons, how many electrons can an atom lose in order to attain a stable electronic configuration, or how many electrons can it gain to attain a stable electronic configuration? We can define valency in any terms, right? So variable valency is like there are some elements in which the electrons can be lost from their valence shell as well as their penultimate shell. Only those elements can show variable valency, right? D block, most of the D block elements will show variable valencies, right? So suppose if we take sulfur here, this is not a D block element. It can show variable oxidation states, but not variable valency. Valency of sulfur is only 2. Sodium is 1. Magnesium is 2. Iron, it shows 2 valencies, +2 as well as +3 valence. Right? We need not mention this plus or minus. We need to talk only about this magnitude value. +2 and +3 valency. So this should be the correct answer for variable valencies. Any D block element, if it is given in the option, that will be the correct option. This is for you to take the screenshot. Next question. Valency of argenticus. We have seen that argentum is the Latin word from which we have taken the symbol Ag for silver, right? Argentum. This is a symbol of silver and we have taken it from the Latin name argentum. And silver, it shows 2 valencies. Most common valency is only +1. It exhibits +1 valency and then it exhibits +2 valency. Okay. +2 valency can be seen in AgF2, silver halide, silver fluoride, right? Okay. So not all halides, but in silver fluoride. If it is lesser valency, then we call it as Us. If it is higher valency, we name it as Argentus +1, argentic +2. It exhibits only 2 valencies, right? So it shows only plus. It forms a cation because it's a metal. So +2. Actually, they are not supposed to ask valency. They are supposed to ask oxidation state when they talk about plus or minus, right? If we are talking about valency, we are not bothered about minus sign. Suppose if we take oxygen, it is -2. It gains 2 electrons to attain stable electronic configuration. Valency, we just write it as 2, right? If we take magnesium, it loses 2 electrons to attain stable electronic configuration. Valency, we just write it as 2. But oxidation state is +2, right? But still, fine. Next question. Calculate the oxidation number of sulfur in H2S2O7. To find out this, first of all, you should know what is the oxidation state shown by each element. For this, you need to refer other YouTube videos or all. Okay, find out, learn those, then only you can calculate. Otherwise, you cannot. So hydrogen always exhibits, means like an oxidation state of +1, you can see it. And then sulfur always sulfur we need to find out. Here is question mark, right? And then oxygen, we always take it as +2 unless and until it is -2, unless and until it is peroxide. If it is peroxide, then it will not be -2. Okay, right. Now, this is not a peroxide compound, so we are not bothered about. We consider it as -2. So H2S2O7. So 2 into plus 1 plus 2 into, for sulfur we need to calculate, it is X, plus 7 into, for oxygen it is minus 2. Overall charge on the molecule is 0, so I'll equate it to 0. Then I'll get this as 2 plus 2x minus 14 is equal to 0. So 2x minus 12 is equal to 0. X is equal to, if it goes this side, I'll get it as plus 6, right? I'll get this as plus 6. So plus 6 is the oxidation number. Plus 6 is the oxidation number. Generally, the valencies that are exhibited in the compounds, we consider it as their oxidation numbers. Right. Next question. The cause of redox reaction is, what is redox reaction first of all? Redox reaction, RED stands for redox, red plus ox. RED stands for reduction. OX stands for oxidation. Stands for oxidation. Any reaction in which reduction and oxidation are taking, means like are going on simultaneously, taking place simultaneously, we consider it as redox reactions. So if something is undergoing oxidation, then it will be losing electrons. Loss of electrons, LEO, loss of electrons is defined as oxidation, right? Gain of electrons is defined as G, gain of electrons as reduction. This you have learned it in your class 9. Loss of electrons is oxidation, gain of electrons is known as reduction. Now, if something is losing electrons, mean there will be some atom which is gaining electron also, right? So if both are taking place simultaneously in the same reaction, we consider it as redox reaction. So redox reaction will be something which will be talking about transfer of transfer of electrons in the reactants, but not in the products, right? Suppose if I write it as A plus B gives rise to C plus D. Transfer of electrons between A and B. I'm not going to talk about C and D over here. So it is something which is related to only reactants. So transfer of electrons between two reactants will be the correct answer. Let us see even the other options. Transfer of neutrons, no, wrong. Exchange, there is no way related to this. Transfer of electrons between two products. This is talking about products, so this is wrong option. Transfer of electrons, but between two reactants. This will be the correct answer. Next question will also be related to redox because I have placed questions that way. This is for your meaning, like if you want to understand more about this, then you can check back these solutions. Which of the following decomposition reactions is not a redox reaction? Okay. To identify a redox reaction, we need to identify the change in the oxidation state for the element on the reactant side and on the product side. Otherwise, we cannot identify whether the reaction is a redox reaction or not. But they didn't give you any reactions over there. So you need to write the reactions, right? But instead of doing all those things, simple method, what you can do to identify the correct answer is any decomposition reaction that is involved with the formation of the product as element, meaning element hydrogen or oxygen or metal is going to form as an element. Element is formed as a product or element is seen in the reactant side. Then definitely it will be a redox reaction, right? You need not work out, you need not write the entire reaction and work out with the oxidation states. So here sodium hydride, if I take sodium hydride, formula of this is this. Decomposition, I already told you, reactant will be one, products will be more than one. So if at all it needs to split, it needs to split in its constituent elements. It will split into its sodium and then hydrogen, right? I'm not writing the balanced chemical equations. These are only skeletal equations. So elements are getting formed. So this should be redox reaction for sure. This is a redox reaction. We are trying to identify which is not a redox reaction. And here potassium chloride, KClO3. KClO3, when it undergoes decomposition, it forms KCl plus O2. Again, we are able to see element formation. So this will also be a redox reaction. Dihydrogen monoxide is nothing but water. Water is known as dihydrogen monoxide, chemical name of this. So when it undergoes decomposition, again it forms elements H2 and O2. Formation of elements or element is involved. Suppose if I write C plus O2 gives rise to O2. CO2. C plus O2 giving rise to CO2. Then elements are involved. This should be redox reaction for sure. Suppose if I write magnesium plus chlorine giving magnesium chloride. Then elements are involved here. This should be for sure redox reaction. Elements we are able to see on the reactant side or on the product side. That will be a redox reaction, right? Now coming to calcium carbonate, because we have ruled out all the three, this should be the correct option for sure. We can use elimination method, right? We need not keep on writing all the reactions, finding out the oxidation numbers. That's not possible at all, right? Because time management is also there. Calcium carbonate. Calcium carbonate, when heated, it gives calcium oxide plus carbon dioxide. So when you find that oxidation states, calcium is +2. Here carbon is +4. Oxygen is -2. We need to find out actually, right? Okay. Calcium here is again +2. Oxygen -2. Carbon +4. This is -2. Are you able to see any change in the oxidation states of any of the elements on the reaction sides and on the product side? If I take calcium, there is no change in oxidation state. If I take carbon, there is no change in the oxidation state. If I take oxygen, -2 here, -2 here. There is no change. So no change in the oxidation states on the reactant side and on the product side. That's why this is considered to be a non-redox reaction, not a redox reaction. So this is the correct answer. I'll show you if you want, you can take the screenshot and work out on these reactions. Let me check chat. Good. Okay. Now I'll clear out all my drawings. Next question. This is also something related to redox reaction only. Which of the following statements are true based on this given reaction? Right? Now, to answer these options, you need to work out with the oxidation states. Let us check in. Here, nitrogen, if I calculate NH3, there are 3 hydrogens, so its valency is -3. This is +1. -3 +1. Here, oxygen. In elemental state, it is always 0. The oxidation state of any element in its elemental state is 0. Now, nitrogen, NO. We know that oxygen is -2. So here, nitrogen will be +2. Otherwise, we would have got the charge over here. So this is +2. This is -2. Coming to H2O, hydrogen is +1 and oxygen is -2. Now, let us see the change in the oxidation states. Nitrogen is changing from -3 to +2. Nitrogen change we are able to see from -3 to +2. So is it gaining electrons or losing electrons? What is happening to the oxidation state? Oxidation number is increasing. Increase in oxidation number is oxidation. Oxidation. Increase in oxidation number is oxidation. Now coming to oxygen. From 0, it is changing to -2 over here as well as -2 over here. Coming to hydrogen, +1 here, +1 here. There is no change in oxidation state. So oxygen is changing from 0 to -2. Meaning what is happening to its oxidation state? Oxidation number. Oxidation number is decreasing. decrease in oxidation number is reduction. Because when can decrease in oxidation number happens? When it gains electrons. Gaining of electrons is reduction. Losing of electrons is oxidation. So nitrogen is getting oxidized, oxygen is getting reduced. Nitrogen gets oxidized is the correct option. Oxygen gets oxidized, wrong. Nitrogen gets reduced, wrong. Oxygen gets reduced should be the correct. Sorry. So A and B, no. C and D, no. A and D, yes. This should be the correct answer, right? I guess in the key they have given B and C, but this is the correct answer, right? So A and D, this should be the correct option. If you want, you can take the screenshot of this. I have given the reaction. No. As well as shown the change in the oxidation state. Next question. Find out why silver chloride turns gray in sunlight. Any silver halide compounds in the presence of sunlight undergo decomposition reaction. Suppose if I take silver chloride in the presence of UV light, gives silver plus chlorine. Silver plus chlorine. Please, I am not writing any balanced chemical equations. I am writing skeletal equations only. So here this is white in color, gets converted into gray. This is all because of decomposition, right? And this is also a redox reaction because you can see elements being formed due to the decomposition of silver chloride into silver and chlorine by light. Exactly correct. Due to the displacement of silver, this is not a displacement reaction. Due to redox reaction, this is a redox reaction. But reason is not due to redox reaction, right? Primary reason is because of the decomposition. So I can't consider this as an option. No doubt this is a redox reaction. Due to rusting of silver in the presence of oxygen. No, wrong. So the correct answer is 1. Next. This is what is the equation. Instead of silver chloride, if you take silver fluoride, if you take silver bromide, then also you can see silver iodide. All the generally we don't talk about silver fluoride. We talk about silver means like chloride, bromide, or iodide. Okay, in the decomposition reactions, you can come across these. What I say is in your examinations. Next question. When haloalkanes and aryl and vinyl halides react with magnesium metal, they yield which reagent? Whenever you see magnesium and they are asking about reagent for you, blindly you can pick for Grignard reagent. Because Grignard reagent is something which is formed from alkyl halides reacting with magnesium in the presence of ether, right? RMgX is known as Grignard reagent. You can see magnesium as a metal. Wherever you see magnesium as a metal and they're asking about reagent, answer will always be Grignard reagent. Coming to Hinsberg reagent, there won't be any metal in this. This is benzene sulfonyl chloride. Phelin's reagent, you can see metals, copper as well as sodium. Okay. So copper sulfate can be seen in this. So if you see copper plus 2 ions given or copper metal given and asked about the reagent, then Phelin's reagent will be the correct option. Tollens reagent, you can see silver. Okay, silver metal in that, right? They can't give you sodium and then ask about Phelin's reagent. For sure, they are supposed to give copper, right? These things you can memorize for you to take screenshot. And also the usage I have written over here. Which reagent is used under what scenarios? If you go through next time, any question asked related to their usage, you can answer. Going ahead, Grignard reagent is represented as. So option is very easy. RMgX, where R is alkyl group and X is halide group. Halide. It can be any halide, right? So generally, what are halides? Chlorine, chlorine, bromine, and then iodine. You can see chlorine, bromine, and iodine as well, but generally we don't find F. So being asked in your examinations. So alkyl magnesium chloride. This is the correct answer. This is how we get Grignard reagent. Excuse me. Which of the following is a saturated hydrocarbon? Okay. Saturated hydrocarbons are those which have the general formula CnH2n plus 2. And this is the only option which is having this formula, CnH2n plus 2. Right? This is the correct answer. Guys, let us go for a question and answer session. Please, if you have any doubts, you can ask me. You can put it in the chat if you don't want to ask me directly in the session. Last 5 minutes we'll have a question and answer session. Till then, let us see few more questions. These are also related to hydrocarbons. Which of the following has the highest boiling point? Alkanes are single bonded hydrocarbons. Double bonded hydrocarbons are alkenes. Alkynes are triple bonded hydrocarbons. And the free carbon dioxide, this has no relation with this. Free carbon dioxide, anyway, it is in the gaseous state, meaning it will be having least boiling point. In hydrocarbons with triple bonds will have high bond energy. So to break those bonds, we need to spend more amount of energy. So obviously, these are the hydrocarbons will be the having the highest boiling points, right? Alkynes. Okay, next question. What is the color of the flame when unsaturated hydrocarbons burn? Very simple, guys. For the same amount of the fuel, we are supplying same amount of oxygen, let us say. If I take a saturated compound and an unsaturated compound, saturated means CnH2n plus 2. Unsaturated, it can be either CnH2n or it can be CnH2n minus 2. So if you see the general formulas, it is clear that relative to hydrogens, carbon will be in more number in unsaturated hydrocarbons compared to in the saturated compounds, right? So if you take same amount of fuel and if you are supplying same amount of saturated and unsaturated fuels and you are supplying same amount of the oxygen, then always unsaturated compounds go for incomplete combustion because more amount of the carbon atoms, they need more amount of oxygen for combustion, right? So oxygen will be insufficient. Whenever oxygen is insufficient and combustion is incomplete, always you can see yellow flame. Always yellow flame. Let us say you have taken a saturated compound, but in plenty, and oxygen is limited, then also you'll get yellow flame. But if for the saturated compound, for the same amount of oxygen, if the flame is blue, then if you take unsaturated, for sure it will be yellow. Right? This is what you need to understand and then answer it. Explanation part, if you want, you can take the screenshot of this. Next question. Name the straight chain alkane having chemical formula seen. Just now we have talked about alkanes will have the general formula CnH2n plus 2. And this is an alkane which they have already mentioned about. Because it is C9, depending upon the number of the carbon atoms, we'll name the compound. If it is 1, we'll name it as methane meth. If 2, eth. Like that C9, it is nonane. I have come up with a table, you can check it. Take the screenshot of that if you want. Right? Meth, eth, prob, but, pent, hex, hept, oct, non, deca, undeca, dodeca. Right? Next question. Which of the following organic compounds is synonymous with olefant gas, which is used to make anesthetics, refrigerants, and other chemicals? Without even thinking, you can go and take it for ethylene. Because the olefant gas, this has been derived from the Latin name oleum, meaning oil-forming substances. It is the ethylene which was historically used for making, in making use of the oil-forming substances. Other than that, it can be used as anesthetics, refrigerants, and also in making up of alcohol, in making up of plastics. Right? So ethylene is the correct answer. This is for you to take the screenshot. 1,3, next question. 1,3-dimethyl benzene is also known as 1,3-dimethylbenzene. Suppose if I take benzene, this is how its structure looks like. If I put on the first position methyl group, then it is toluene. If I put it either on this side or this side, wherever I put another methane, right? Because they have mentioned in the third position, let me have it over here. Xylene, metaxylene. If I put it just over here, orthoxylene. If I put it here, paraxylene. Two methyl groups attached to a benzene, xylene. One methyl group attached to benzene, toluene. Right? You can see their structures and take the screenshot if you want. Next question. Yeah, we can go for question and answer session, guys. Pepperoni, ethyl acetate, butyraldehyde, and nitrate are all common adulterants used in ice cream. Ethyl acetate is something which is used to enhance fruity smells. Butyraldehyde used to enhance butter flavor. Pepperoni to enhance any kind of flavors. It makes it a little bit more enhanced, right? Nitrate is used as a preservative. And the next question. This is not that important. Let's go ahead and see another one. A class of organic compounds that contain an oxygen between two alkyl groups is called. Yes. So this is important part. Oxygen between two alkyl groups. Alkyl group here, oxygen here, here. All these compounds are known as ethers. Suppose if I have R, O, and H, these are known as alcohols. If I have R, C, double bond OH, these are known as aldehydes. I'll write straight away over here. These are aldehydes. These are aldehydes. R, OH, these are alcohols. Ether, R, O, R. Ketones, R, C, double bond O, R. Either side alkyl groups, but in between carbonyl group. One side R, one side H, and between carbonyl group, aldehyde. This is a basic difference between these two, right? Next question. Which organic compound has a pleasant almond aroma that is commonly used to impart almond? Anywhere, wherever you see almond flavor, answer will always be benzaldehyde. Benzaldehyde. Almond flavors, butter flavor. Okay. So butyraldehydes, butter flavor. Aldehydes are used to give these kinds of flavors. Next question. Which of the following acids makes up 55 to 80% of olive oil, making it a good choice for most cooking methods? Within the name itself, we have that answer. That is oleic acid. Lauric acid will also be there, but it is negligible. You almost consider it as nil, right? Arachidic acid, you can find it in peanut oil. And then stearic acid, you can find it in most of the animal fats as well as plant oils. Okay? Plant seed oils, you can find this. So correct answer is oleic acid. You can also see palmitic acid and then linolenic acid. Next question. Yeah, this is the last one which I'm going to discuss. Which of the following is a straight chain alkyl carboxylic acid with the chemical formula? This one. To answer such type of questions, you just need to count number of carbon atoms. 4 carbon atoms, but. So the answer will be 4 carbon atoms means butyric acid. If 2 carbon atoms, ethanoic acid. I'll show you the page, you can take the screenshot. 1 meth, 2 eth, 3 pro, 4 but. That's where you are going to answer. Right? Okay, guys.